Our new topic for today is working with a set of identities. Identities are simply rules. They're rules that we are able to do substitutions with to help us simplify an expression. So rewrite an expression a different way. So our identities for today are the ones in the red box on our handout of identities. They're the reciprocal identities, the quotient identities, and the Pythagorean identities. We are not going to see a whole lot of these even odd identities, so you could think about just crossing those out. Now, these identities are exactly as they appear. Some of these can be rewritten different ways, and we would use them to help us do substitutions. So for example, if I look at this very first one right here, cosecant theta is equivalent or equal to 1 over sine theta. That means that where there's a cosecant in a question, I could take it out and replace it with a 1 over sine theta. So these identities are used to help us do a substitution. Now, a couple additional things about our identities. The first is that the reciprocal identities and the quotient identities can also be squared. So if, for example, I'm looking right here at cotan theta is equal to 1 over tan theta, I could also square both sides of that expression and have a true statement. So I could say cotan squared is equal to 1 over tangent squared. Now, just so we're clear, when I say cotan square and the square is on the t like that, that means cotangent of theta squared. Or I could write it as cotangent of theta times cotangent of theta. We typically put the square where we do so that there isn't any confusion about whether the whole ratio is squared or just the angle. So I can square the reciprocal identities and I can also square the quotient identities. Cotan squared theta is also equal to cosine theta over sine theta. These are ones that come up quite frequently, and those are the Pythagorean identities. So the most common one is sine squared plus cosine squared equal to 1. Here, I'm going to highlight it red. This one's going to come up most frequently. And the nice thing about this is I can also rewrite it. I could say sine theta is equal to 1 minus cosine squared theta if I subtracted cosine from both sides. I could also say cosine squared theta is equal to 1 minus sine squared. So anytime I see an expression where I have a squared piece and something being added or subtracted to it, that's where these Pythagoreans pop up most frequently. So we can say 1 equals secant squared theta minus tan squared theta. So having these rearranged versions can be really helpful, and having them close to where you're doing your work is also a good idea. Now, what we're going to be doing here is we're going to be verifying expressions today. Now, what that means is essentially like a two-column proof. You'll be given something and you're being trying to prove that it's equal to something else. The ways ours are going to look though is it's going to look like an equation. You want to take one side, like the left-hand side, and turn it into the right-hand side. And you're going to do that with a combination of the identities we just saw in the red box and some algebra skills. So here are some strategies that help. The first strategy, and this is probably something that you're going to do most frequently, and that is change everything into sine and cosine. Everything can be written as sine and cosine, and if you can write everything as the same, you will see what things cancel and what things can come together. The second one, if you have a squared term, look for one of two things. Is it a Pythagorean identity, or is it maybe a squared quotient or squared reciprocal identity? The third thing, if you have a fraction, can you break it into two fractions? Can you take two fractions and combine them with a common denominator? Could you multiply by a conjugate to help find one of your Pythagorean identities? And finally, could you factor out a GCF? And I'm going to add one more here. Can you multiply together? Don't be surprised if at some point you get stuck and do the wrong thing. It takes practice. So here's what our questions are going to look like today. The directions ask us to verify the following identity, and what it appears to be is an equation. So the first thing I'm going to do here is I have cut or copied this chart, and I'm going to keep it here so that I can continually reference it. And I recommend that. These are what we can work with. So when I do a verify question, I'm going to start by drawing a line down the equal sign. I cannot cross that line. I'm going to pick either the left side and work on that, or the right side and work on that, and try to turn one into the other. So it's kind of like saying one side is the given, the other side is the proof of a two-column proof. Now, when I look at this question, I would like to work with the left-hand side because it's the more complicated side. There's not necessarily a correct answer to which side you have to work on. I just say work with the side that is more complicated because you have more options. So I'm going to work with the left-hand side. And what I notice about the left-hand side is this tangent, tan theta. Our first recommendation for how to verify is to turn everything into sine and cosine. So tangent is not sine or cosine. So I'm going to go look in my red box. I see that tangent's equal to 1 over cotangent, and I also see that tangent is equal to sine over cosine. So I want to try to turn everything into sine and cosine. So I'm going to work with this sine over cosine one. So the cosine theta is going to stay the same. Tangent's going to turn into sine theta over cosine theta. I'm just going to try to highlight it so you can see what we're doing. So now that I have cosine theta times sine theta over cosine theta, I can cross out these two cosines. They cancel each other out. And what I'm left with is just sine theta. Well, that's what I want it to turn into. So I'm done. Your end work is the answer, is seeing all of those steps.